This is a follow-up to the loop rule with 2 batteries lesson. In that lesson, we decided that the current in this circuit is going to be counterclockwise. And that was because we noticed that this was 12 volts and this was 3 volts. And since they're pushing, the 2 batteries are pushing the current, the 12 volt wins the push of war. So suppose that we decided to make the current with respect to this one, and we said the current goes clockwise, like that. Okay, so that's the decision we make. That decision is random, although logic can often help us solve the problem quicker. So that's the current right there. So I'm going to apply the loop rule. The loop rule says that the sum of the voltage is equal to 0 in any loop. I'm now going to begin at the 3 volt. So we start off with 3 volt, and then we get a voltage drop right here when we encounter the first component. So that's minus I times 4 IR. Remember, V is equal to IR. That's why I'm doing that. And then I'm going to encounter this 12 volts, but it's working against us. So that's a voltage drop also of 12. It's not a voltage gain because it's working against us. And then we encounter the next resistor, and that's working against a 3 volt battery. So we have I times 2, and that's equal to 0. So here we have 3 minus 12, that's 9. And 4 and 2 would be I times 6. And then I is going to be equal to negative 9 divided by 6, which is negative 1.5 amps. Okay, so this negative number, what that means, we picked the wrong direction. Okay, so what does that mean? That means the current is actually in that direction. Actual direction of current. So that's how we resolve if we end up getting a negative current calculation.